Alright, we're going to be doing 4 problems. We're going to be using ratios and right triangles. Something I want you guys to do in your journal, alright? I'm going to bring up something right here. Something you're going to want to make sure that you understand is these trigonometric ratios right here. So if you're watching this video, you might want to pause it and just write those down in your journal, because we're going to be using sine, cosine, and tangent. Alright? So, in your journal, if you're doing this, you could also write so, ka, toa. Alright? So, this means sine. So, sine, the relationship is always the opposite over the hypotenuse. Cosine, the relationship of the adjacent side over the hypotenuse. And tangent is the relationship of the opposite side over the adjacent side. So that's something you're going to want to understand, like, what does that mean? Like, if this is theta, the measure of your angle, the side that's across it is called the side that is opposite. The hypotenuse is always across from the 90-degree angle that you can see right here, and the adjacent side is what's left over, the one that's next to, right? Adjacent means next to, so just next to the angle, other than the hypotenuse. So you're going to be using these ratios when you're working on these problems. All right, so let's take a look at the very first problem. So we have some right triangles here. We've got right triangle 1, 2, and 3. All right, and so it says use one of the triangles to approximate EF in the triangle below. Well, what I'm going to do is I'm not even going to use those. Okay, what I'm going to do is I'm just going to do some trigonometry here with you, and then you can use that. You don't have to worry about comparing. You can just know how to do it. So here's your right triangle. Could you please put a little arc next to the 20, and then I want you to draw an arrow going across, and that is what we call our opposite side. All right, this side that's across from the 90-degree angle, that is your hypotenuse, which means the 6 right here represents the adjacent side. Now when you're doing trigonometry, you always need to know what do you have and what do you need to find. Okay, so what do we need to find? We need to find EF, so we need to find our opposite side. What do we have? We have our adjacent side. So if you're going to use this little SOHCAHTOA, which I'm sure your geometry teacher taught you. All right, SOHCAHTOA, which one are you going to use? The opposite and the adjacent? I'm going to use tangent this time. So I'm going to say the tangent of 20 degrees is equal to the opposite side, I'm just going to call it x, because I want to find EF, over my adjacent side, which is 6. Now, I set this up as a little ratio. I do x times 1, which is x, and I do 6 times the tangent of 20 degrees. Now, whenever you're doing this, you got to make sure that whatever calculator you have, you got to make sure it's in degree mode. So all I'm going to do right now is type in 6 tangent 20. 6 tangent 20, press enter. I get 2.18 or 2.2, so I'm going to look for an answer that's approximately equal to 2.2. That would be the side length from E to F. So let's look for 2.2. Okay. Oh, there it is, 2.2. All right, let's look at the next one. Ooh, we got another right triangle. All right. So it says use the ratio, yada, yada, yada. I'm just going to say forget you ratios. I'm just going to find what would be my comparison from WY over WX. Well, what is WY? WY is this side. Okay? All right? And WX is this side right here. So right now, here's my angle. There's 70 degrees. All right? Here's WY. I'm going to put that's my WY. This is my WX right here. So right now, if I use the 70 degrees, what side is this? This is my opposite side. This is my adjacent side, and this is my hypotenuse. So what am I comparing? I'm comparing my adjacent side with my hypotenuse and the 70 degrees. So if I'm going to use SOHCAHTOA, which one compares the adjacent and the hypotenuse? The cosine, adjacent, hypotenuse. I'm just going to write, ready? The cosine of 70 degrees. So I'm going to use cosine to find my ratio. So what is the cosine of 70? Well, I don't know off the top of my head. I'm just going to type the cosine of 70, and I get 0.34. So I'm looking for the answer that is 0.34. So I'm going to choose answer choice A. All right, so hopefully that made sense to you. I used it from 70. I compared my adjacent to my hypotenuse, which is cosine. I typed it in, cosine of 70, and I'm done. So right here, we're going to look at this, and we're going to find M to O. We're going to find the hypotenuse right here. So I'm going to label that X. So what we're going to be doing is solving for this length right here. So whenever you have a right triangle, this is what you guys need to do. Highlight the angle that they give you, okay? Maybe draw a little arc there, highlight it, just keep it right there. Then what I want you to do from there is I need you from that angle to draw an arrow which goes across and always label it the opposite. The next thing that you need to do is you need to label your hypotenuse. Well, X happens to be our hypotenuse, and this 2 happens to be our adjacent side. So right now, what do we need? We have our adjacent side, but we need to find our hypotenuse. So this is where you write SOHCAHTOA. SOHCAHTOA. Now, what does SO represent? That's our relationship of sine. Ka is cosine. Toa is tangent. So since we have the adjacent and the hypotenuse, I'm going to be using cosine in this particular situation because I have the adjacent and the hypotenuse. That's the A and the H. So I'm going to write the cosine of 75 degrees is equal to the relationship of my adjacent side to my hypotenuse. And I just make a little proportion. Now once I make my proportion, it becomes very easy. All I have to do is just cross multiply. When I cross multiply, my cross products are x times the cosine of 75 degrees equals 2. Now whenever you get this situation, you need to divide both sides by the cosine of 75 degrees. Okay? And when you do that, you're going to get the answer. But your calculator must be in degree mode. So right now, let's go to the calculator. I'm going to make sure my, I'll go make that a little bit bigger. Make sure my mode is in degree mode. It is. All right. And I got to do what? 2 divided by the cosine. So I got to go 2 divided by the cosine of 75. And I get approximately 7.7. All right. So I'm looking for an answer that says 7.7 units. So let me see if I can find that. So 7.7. Hey, right there. Answer choice D. All right. Let's go ahead and take a look at this problem right here. It says use the table to approximate the measure of angle Q. Well, I'm not going to use the table. I'm just going to go ahead and solve it. All right. So right here, the first thing we do is we make a little arc. Oh, they already made it right there. So once you make the arc, we're going to draw an arrow going across, and that little arrow points at our opposite side. So the first thing we always do is label our opposite side. Next thing I do is I label my hypotenuse. Okay, that's supposed to be HYP. Okay, that's my hypotenuse. All right, which means this right here is my adjacent side. So they've given me my adjacent side, and they've given me my hypotenuse. So if we write our 3 basic trig ratios, SOHCAHTOA, all right, this we're dealing with cosine once again because they've given us the adjacent side and the hypotenuse. We're trying to find the measure of this angle. So here's how you find the measure of an angle. You set it up. The cosine, and we're going to call it capital Q, that's the angle that we're looking for. The cosine is equal to the ratio of our adjacent side, which is 2.5, over our hypotenuse, which is 4.4. Now, something that you can't do, you can't divide both sides by cosine, but we have what's called the inverse, all right? The inverse of cosine. So I can apply what's known as the inverse of cosine, and I can apply what's known as the inverse of cosine to both sides. So these will cancel each other out. So think of like 1 over cosine times a cosine over 1. They cancel to a 1. So we're left with our angle. All right, so right here, capital Q will approximately equal the inverse of cosine of 2.5 over 4.4. So right now, go to my calculator. Make sure, once again, make sure you're in degree mode. If you're not, it's not good. All right, and then you hit second cosine, and you type in 2.5 over 4.4. 2.5 over 4.4. Okay, and there we go, 55.4 degrees. So it's approximately equal to 55.4 degrees. Now, if you don't have this graphing calculator, you also can do it in Desmos. Let me see if I can go to Desmos real quick. You can go over here, make sure you're in degree mode, and then you can use Desmos, go to functions, and go to inverse of cosine, and you could type in 2.5 over 4.4, and you could still use Desmos as a free graphing application to get your, as your calculator if you don't have like a TI-84 plus CE or an Inspire or something like that. But make sure, like I said, make sure you're in degree mode when you're doing it, otherwise it won't work. Watch. Ooh, that'd be bad. See radians? No, we want it in degrees right there. All right, so go ahead and find it. 55.4. Oh, 55. We'll just choose 55. All right. All right. So there we go. That's using ratios and right triangles, but I really didn't. I just kind of solved them straight out. So right now, let's go ahead and look at, these are going to be super, super, super easy, okay? So on this one, it says, what's the tangent, all right? What's the tangent, basically, of angle A, all right? What's the tangent of angle A? So right here. Now, the tangent is always the opposite side over the adjacent side. So what is my opposite side? My opposite side is 35. What is my adjacent side? My adjacent side is 12, because 37 is obviously my hypotenuse. That's across from the 90-degree angle. So I'm looking for the ratio of 35 over 12. So this one's going to be super, super easy. Okay. Over here it says, what's the sine? All right. What's the sine of capital B? All right. All right. So we have, this is beta. The other one was alpha. All right. So if you're wondering what that was, all right, that's the alpha symbol, but there's capital A. This is beta. This is capital B. So we're trying to find the sine of B. Now the sine is always equal. All right. The sine of capital B is always equal to the opposite side in relationship to the hypotenuse. So we're going to draw a little arrow, go into the opposite side, label it. So it looks like our opposite side is 4. And our hypotenuse right here, you can clearly see, is 5. So that's just 4 over 5. That's how easy it is. All right, so 4 over 5. Let me just choose 4 over 5. Okay, here we go. Right now, once again, we have alpha. So it says, what's the cosine of alpha, or cosine of A? So what is the cosine of A going to be? It's going to be my adjacent side over my hypotenuse. So we got to find the adjacent side. So what do? I always draw my arrow. That's my opposite side. This is my hypotenuse. This is my adjacent side. So I'm doing adjacent over hypotenuse. So this is going to be 35 over 37. And that's it. This is why putting this box right here in your journal. Why won't I just go there? Please just let me draw the box. All right, that's why it's important to put this into your journal. Now, something you also need to be aware of, all right? And you can put, we didn't have to use this in this particular case, all right? But sometimes you might see the word cosecant, all right? Or you might see the word secant or cotangent, okay? Now, I want you to understand how easy this is. Cosecant is simply the inverse of, like it's the flip, it's the reciprocal of sine. So if this is the opposite over the hypotenuse, cosecant, also written as CSC, is the hypotenuse over the opposite. So put HYP over OPP. All right? Secant is the hypotenuse over the adjacent side. So if it's easy to remember as just H over O and H over A, that's totally okay. All right. Now secant, the abbreviation is SEC. All right, not the Southeastern Conference where those football players live and play, but SEC, secant. All right, and cotangent is the reciprocal of tangent. So instead of the opposite over the adjacent, it's going to be the adjacent side over the opposite side. So we could say it's A over O. So these are just and that's also COT. So if you go to your graphing calculator, you can kind of see them. Well, I can't really see them here, but if you go to Desmos, you can. Let me go to Desmos. I'll type right here, functions. All right, so, well, that's the inverse. Well, I guess you can't see the actual words, but understand CSC means cosecant, SEC means secant, COT means cotangent. So you might have to use those every once in a while. All right, so this one we're just going to choose what? 35 over 37. 35 over 37. There we go, right there. All right, and that's all you got to do. All right, so if you want to, just make sure you go back and watch how we solve for different sides and solve for different angles. The only time you ever use the inverse button is when you're trying to find the measure of an angle. So on, where was that problem? Right here. This is the only time you have to use what's called the inverse of cosine if you're trying to find the measure of an angle.